So in this video, we're going to talk about compound probability. Compound probability is just a probability involving two or more events. In other words, event A and event B happening. So let's say, what's the probability of flipping a coin twice and getting heads both times? So we would write it, the probability that one flip comes up heads. Remember that we write probability as the number of ways an event can happen over the total number of outcomes. So to find the probability of getting one head, well, the number of ways it can happen, 1, because there's only one way to get heads on a coin, over the total number of outcomes, 2. So the probability of flipping a coin and getting heads is 1/2. That's also the probability of getting tails. So going back to our original question, the probability of flipping a coin twice and getting heads both times. So that means we need to do the probability of the first flip being heads and the probability of the second flip being heads. So if we draw it out, all of our different ways, we call this the sample space. It would look like this. This represents all of the first things we could get. We could get head, head, or tails, tails. This was what our first coin would give. And then our second coin could be heads, tails, heads, and tails. In other words, we could get two heads, a heads and a tails, the tails and a head, or tails and a tails. There's 4 different possibilities that we can get when we flip two coins. So, first flip coming up heads is going to be 1/2, and the second flip coming up heads is going to be 1/2. In other words, there's 1 in 4 chance that we get two heads. We saw that over here in our sample space. Only 1 out of 4 of these came up two heads. So that gave us our 1 in 4 chance. If you notice, we had a 1/2 chance here and a 1/2 chance here. I could have multiplied these two and seen that we had a 1/4 chance. Which leads us to talk about our next thing, which is called the multiplication rule. The multiplication rule says that for two events, A and B, if the events are independent, then the probability of both events happening is the probability of A times the probability of B. Remember that an independent means that one event is not dependent upon the other. So let's talk about compound probability and replacement. Example 2. In a bag we have 4 blue marbles, 6 green, and 3 yellow marbles. If 2 marbles are chosen at random, let's see example 2A. Probability of getting a green and a yellow with replacement. In other words, I'm going to draw one marble, put it back in, and draw another marble. So the probability of getting green is going to be 6 out of 13 marbles, because there's 13 marbles in the bag and 6 of them are green. So I'm going to draw out my green one, see what color it is, put it back. 6 in 13 chance. Then I'm going to draw my second marble. I'm going to draw it out and see what color it is. Well, there's 3 yellows, so the chance of my second one is 3 out of 13. So to find out the probability of getting both green and yellow, I would take my 6/13 that represents green and multiply it times my 3/13 that represents yellow. Remember, when you multiply fractions, you multiply across the top and bottom. So 6 times 3 is 18 over 13 times 13, which is 169. Remember that probability should be written as a number between 0 and 1. So I divide 18 by 169 and I find out that my probability, of getting green and yellow is 0.107. Okay, what about without replacement? That means that after I draw that first marble, I'm not going to put it back. So for my second draw, there should be 1 less marble in the bag. So again, my probability of green was 6 out of 13. But when I go to draw the yellow, there's still 3 yellow marbles in the bag, but there's only 12 marbles. So this time, 6 out of 13 times 3 out of 12. I still have 18, but I only have 156 on the bottom. So this time, the probability is slightly higher because I reduced the number of marbles the second time. So again, replacement, and without replacement I should say, is just referring to whether or not you put something back into the pot or the bag that you are selecting from. Okay, geometric probability. Geometric probability is a probability that is found by calculating a ratio of lengths or areas of a geometric figure. We'd still say the probability of the event number of ways the event can happen divided by the total number of outcomes. This time, number of ways the event can happen is going to be the area of the event divided by the total area. So if we look at this figure, we have this rectangle and this square. We want to find the probability that a point is in this square. Let's say we were going to throw a dart and we want it to land in this square, this 3 by 3 square. So our probability can be found by taking the event area and dividing by the total area. Well, our area of the square is going to be 3 by 3 or 9. The area of this rectangle is 6 times 8 or 48. 9 divided by 48 is 1.1875. So the probability of throwing something and having it land in this square is 0.187, or 0.1875, excuse me. Okay, look at example 3b. Probability that a point is in the shaded area. So this time, it can land anywhere except the square. So I would take the area of the rectangle minus the area of the square. So that's how I'm getting the area of our shaded area. And I'm going to divide it still by the total area, or 48. So 48 minus 9, and then I'm going to divide it by 48. This time, our probability is much larger, which makes sense because this time it has a much larger area to land in. And that's how we deal with compound probability in our multiplication rule and geometric probability.